Section 4.2 notes. The objective here is you should be able to find the length of segments using segment addition, and you should be able to find the length of segments using congruent segments. Okay, let's review what a segment is. Okay, so again, a segment is a part of a line that has two defined endpoints. Well, measuring segments, we are trying to find the distance from one endpoint to another. So for example 1, we have these defined points on a number line. So now you notice that the location of some of these endpoints are on the negative side of the number line, right? But that should not matter when it comes to trying to find the measurements of the segments formed by picking two of those points to be endpoints of a segment. For example, looking at trying to find the length of or measurement of segment AB. All right, so from A to B, we see that A is on -8 and B is on -5. But again, we're trying to find the distance or the length between those 2 points. So if we count 1, 2, 3, so 3 spaces away, so the length of AB is 3. Do the same thing for B to C. 1, 2, 3. And from C to E. Right. 1, 2, 3, 4. Now the segment addition postulate goes like this. Right. We take segment AB and we add to that the length of segment B to C. That would equal segment AC. All right. Now you notice that I am not using the segment sign above the letters. So anytime we do not use the segment line above these letters, that symbol, we are talking about the measurement. Okay, so I should be reading this as the measurement of AB plus the measurement of BC will equal the measurement of AC. For number 1, it says find the length of segment XY. All right, so we see XY is made up of XZ added to ZY, and that equals XY. So we got 7. So the length of XZ. 9 is the length of XY. So that means, ZY. So that means XY has a length of 16. Move on to example 2. We're trying to find the length of XY. So it's slightly different here. All right, so here we're trying to find the smaller piece. All right, so we are going to take the length of ZY and we're going to subtract off the length of ZX, and that will give us the length of XY. 12 minus 5 equals 7. Okay, so let's see what you can do with example number 3. All right, so setting it up using segment addition. For this problem, I'm going to see that AC, the measurement of AC, plus the measurement of CB will equal the measurement of segment AB. Okay, then we sub in those algebraic expressions for those three segments. And that gives us an equation to solve for x. So we get x equals 10. All right, for example number 4, it says if the length of segment BC is 25, find the length of AB and AC. All right, so since we're given the length of BC is equal to 25, and we also have an expression for BC, 7x minus 3, all right, through substitution, we can write this equation to help us solve for x. All right, so we solve for x, we get x is equal to 4. So with that, we were able to find the length of AB through substitution. So we get AB has a length of 6. And to find the length of AC, well, again, now that we found AB is 6, and we know that AC is AB plus BC. And again, AC is AB plus BC. So to find AC, you take the length of AB, the length of BC, and add those together. All right, let me give you some time here to see if you can do example number 5 on your own. Okay, so to start, you're given that FG is equal to 60, and we have an expression for FG. It's 2x plus 30. So putting those together, all right, we come up with an equation that's going to help us solve for x. So using that value of x, I'm going to plug that in to find the length of EF. So when we do that, we get EF is equal to 40. All right, so now to find EG, I'm going to write the equation that EG is equal to EF plus FG. So do a little substitution. We get EG is equal to 100. Okay, so now these last two problems, I am modeling for you how I want you to do these on quizzes and tests. It's very important that you are very detailed on how you are setting up and solving for some of these problems. Okay, sometimes students immediately like just to go right to writing an equation. Right. Can you notice I always started off with what was given, or at least using a postulate. Right. Like for example, again, in this problem, I started off with the given, that FG is equal to 60. And then through substitution, I plugged in 2x plus 30 in for FG. Solving for EF, again, I started off with what's given. Right? I made a statement saying that EF is equal to 4x minus 20. Then I used the substitution to solve for EF. And then finally, to find EG, again, I did not immediately go to writing 40 plus 60 equals 100. I started off by writing a segment addition postulate statement. EG is equal to EF plus FG. Then through substitution, I showed how to find the length of EG. All right, so again, these steps are very important. As I said the other day, that the details, you need to make sure you are writing those down, right? Because the lack of those details will cost you points on quizzes and tests. And the way you remember that is by practicing on homework. All right, so we're moving on to some more vocabulary. And here we're going to talk about congruent segments. All right, so congruent segments are segments that have equal length. And the way on a diagram that you're going to know which segments are congruent is that you will see various what are called tick marks. Okay, so if you take a look at example number 6, you'll see that we have two triangles with various markings on them. So these marks tell you which segments are congruent. So let's take a look at segment AB. It has that one little mark on it. And we also notice a similar mark over here on segment CE. All right, so those tick marks tell you that those two segments are congruent. Okay, so what we're going to do is write a statement of congruency of those two segments. And the way that way is written this way. All right, so segment AB is congruent. This is the congruent symbol. All right, it's an equal sign with that tilde. All right, so segment AB is congruent to segment CE. This is a statement of congruency for segments. Can we see similar markings on AD and CD? So those tick marks tell you that those two segments are congruent. So we're going to write a statement of congruency for those two segments. Segment AD is congruent to segment CD. The other tick mark there, we have segment BD is congruent to segment ED. So again, these statements of congruency are saying that these are the segments that have equal length. All right, so for number 7, we are given a statement that segment PQ is congruent to segment RS, and we are asked to find X. All right, so off to the right here, again, I'm showing you the work that you need to show me on quizzes and tests. We're starting off with what's given. We are given that segment PQ is congruent to segment RS. So what does that mean? That means that the lengths of those two segments are equal. Notice the change in notation. Again, notation is very important in this unit. I now have made a statement about equal lengths. PQ is equal to RS. From the given diagram, we can write an expression for the length of PQ. Through segment addition, it's 8 plus X. The length of RS is 21. So here we have an equation to help us solve for X. All right, X is equal to 13. All right, so let's see what you can do with example number 8 using the givens and finding those specific measurements. All right, so based off of the tick marks, we can see that segment NO is congruent to segment KL. So that means their measurements are equal. And we will substitute the measurement for NO. We get KL is equal to 3. Okay, so let's go ahead and move on to the 4-2 homework.